Hi students, in this video I am going to explain chemical equilibrium degree of dissociation numericals. In the previous video, introduction part of degree of dissociation and two numericals I had explained, and one question I asked you. Even that question I am going to give solution in this video. First we look into the degree of dissociation questions. Question number 1. First, 3 moles of PCl5 is heated in a flask of 4 liter volume. They had given volume. Okay, 4 liter volume. How many moles? 3 moles. At equilibrium, it dissociates to give 40% of PCl3 and Cl2. Calculate equilibrium constant. Okay, now what is the required equation? First, we'll write PCl5, phosphorus pentachloride. It is in gaseous state. It is converting into PCl3. It is also in gaseous state plus chlorine gas. It is in gaseous state, right? See students, the given information, first we have to note it down. Volume, how much volume they gave? 4 liters they had given. If they had given volume means definitely we have to consider. Some numericals they are giving just 1 liter they will mention. Sometimes they are not giving. That means no need to calculate. But here volume, what is concentration? Concentration is nothing but number of moles of the solute by volume in liter. Right, volume in liter. They have given means number of moles by volume also we have to take it. Then only it is concentration. Okay. Equilibrium constant is nothing but concentration of products by concentration of reactants. Concentration is nothing but number of moles per volume. So volume given means volume also we have to take it. Okay. While solving question you will get more clarity students. Now first, what is the next information? At equilibrium, it dissociates to give 40% of PCl3 and Cl2. See, what is this 1 mole? What is this 40% is nothing but 40 by 100. So, you will get here 0.4. So, 1 mole means how much students? 1 mole means 0.4. I gave best trick also in the previous video. If you solve questions like this, it will take less than 1 minute. You will get proper answer also, correct answer. For 1 mole, 0.4. But starting how many moles of PCl5 they had given? 3. This is starting 3. Products is 0. Always starting reactants concentration is more. Products is 0. Right. Now at equilibrium. We have to calculate. 1 mole 0.34 students. Whatever they are given degree of dissociation, you have to consider this is for only 1 mole always. Okay. Then according to the equation, according to the question, it is 2 moles or 4 moles, 1 mole you can. So this is 3 moles. How much? 3 into 0.4, how much students? 1.2. This much dissociated at equilibrium. 3 minus 1.2. If you have taken 3 minus 0.4, your answer will be wrong students. Your answer will be wrong. If you take like this method, then it is easily you can score marks in chemical equilibrium degree of dissociation numericals. Now take stoichiometric relation. Previous video also we have discussed stoichiometric relation. This is 1 mole, 1 mole. 1 mole, 1 mole. Okay, we are talking about this one, how much appearance. Here 1.2, this we have to take it. 1.2, how much? 1.2, how much? That's it. So we will get 1. What is this? 1 into 1.2 by 1. That is nothing but 1.2. Same like this is also 1:1 ratio. No? 1:1 ratio. No? Same thing. You will get here also 1.2. So here 1.2. See, 3 minus 1.2. How much students? 3 minus 1.2? 1.8. This is 1.2. This is, take it as 1.2. Take it as, so it seems to be little clumsy. I am writing with another color. This is also 1.2. Now students, what we will do here? What is the next step? What is this? This is number of moles, just number of moles, right? Number of moles. Now what we will do? Concentration. Concentration is nothing but number of moles by volume in liter. Volume how much? 4 liters. This is 1.8 by 4. This is 1.2 by 4. This is also I am writing here 1.2 by 4. That's it. Clear? So 1.8 by 4, can you simplify? So 1.8 by 4 or nearly 0.45 you will get it. Okay, here what is this? 0.3 you will get it. Here mole 0.3. That's all. Now you got it. What is this concentration? Now you got it, concentration. Then you will calculate equilibrium constant. What is equilibrium constant? Kc equal to concentration of products. What are the products? PCl3 and Cl2. Concentration of products by concentration of reactants, that is PCl5. Yes, you will substitute all these values, you will get answer. 0.3 into 0.3 by 0.45. This is your method. Finally, what is the answer, students? Your 0.2 mole per liter. Mole per liter. This is your answer. Okay, so it is very easiest method. Now next question. Question 2. HI was heated. Required equation first you have to find out. HI was heated in a sealed tube at 400 degrees centigrade till the equilibrium was reached. HI was found to be 22% decomposed, that means dissociated. The equilibrium constant of dissociation is, equilibrium constant for dissociation is. Now how to calculate, students, again? So what is the required equation? HI heated, that means 2 moles of HI heated, it will give H2 gas plus I2, both are in gaseous state. Okay, this is your required equation. Now equilibrium was reached. HI was found to be how much dissociated, students? Decomposed 22%. So 22% means 22 by 100. How much? 0.22. Right, 0.22. So this is for what? 1 mole. I said no, 1 mole. This is for 1 mole. 1 mole 0.22. So now students check it. What is the equation according to the question? Starting how many moles here? They were not mentioned any information about HI, how many moles they have taken. That's why according to stoichiometric equation I am taking. But in the given question, above question, they mention starting 3 moles means, they mention means that only we have to consider. If they are not given, what is the stoichiometric coefficient, that we have to take it 2. This is initially products is 0. That's it. Clear? If they mention means that value, that number. If they are not mentioned means according to stoichiometric coefficient. Okay. Now 1 mole 0.22. 2 moles how much? 2 moles how much, students? 0.44. Yes, you have to subtract 2 minus 0.44. Same methodology. Okay. Now what is this? This is again stoichiometric equation. 2:1 ratio, right? 2:1. This is 2, this is 1. Okay. 2 moles means, what is this, students? What is this? 0.44, 2 moles. 1 mole how much? 1 mole how much? So simplify this one. 0.44 by 2. 0.44 by 2, you will get 0.22. That's it. This is 0.22. Similar way, this is also 2:1 ratio, no? 2:1 ratio. So you will get the same answer, 0.22. 0.22. Clear? That's it. Here volume they are not mentioned. No need to take volume. But before question volume they had given. That's why we have considered. Clear? Now subtract this one. 2 minus 0.44. How much, students? How much? 1.56. This is 0.22. This is 0.22. That's it. Now what they are asking, again here also equilibrium constant, dissociation constant they are asking, that is nothing but Kc. Kc equal to concentration of products by concentration of reactants. Here what is the stoichiometric coefficient? 2. We have to take it as power 2. So before equation only 1 mole, that's why we have taken PCl5, but here they had given 2, no? So whatever they had given stoichiometric coefficient, it is raised to the power according to law of mass action. According to law of mass action, what is the definition? The rate of reaction, the rate of reactants or products directly proportional to the concentration of the reactants raised to the power of stoichiometric coefficients. Stoichiometric coefficients, right or not? So here what is the stoichiometric coefficient 2, that's why. Here 1, that's why not taken. 0.22 into 0.22 by HI whole square. What is HI whole square? 1.56 whole square. If you simplify this one, students, you will get answer 0.0199. This is your answer. It's an easy method. Yes, very good. Now next, go to the next question. To the next question, a certain temperature, at certain temperature 50% of HI is dissociated into H2 and I2. The equilibrium constant is. The equilibrium constant is, again same question. HI dissociated, HI gives rise to H2 plus I2. Equation is same. Information slight changes. Right? At certain temperature, 50% of HI is dissociated into H2 and I2, the equilibrium constant. Again, equilibrium constant. So, whatever they had given dissociation, how many moles? 1 mole. 50 by 100. 50 by 100 is nothing but how much, students? 0.5. Right? 0.5. Now, for 1 mole, how much, students? 1 mole, how much? 1 mole, 0.5. But now, 2 moles, how much? How to calculate? Can you try this one? 1 mole, 0.5. Right. So, for 2 moles, how much? 1. That's it. Right. So, you can write 1 mole, 0.5. But according to the given question, this is 2, this is 0, this is 0. Initial concentration of products is 0. Right. At equilibrium. What happened? 1 mole means 0.5, but 2 moles how much? 2 into 0.5, that is nothing but 1. So means 2 minus 1. This is 2 is to 1 ratio, no? 2 is to 1 ratio, stoichiometric coefficients. So this is 1, how much this is? 1 by 2. This is 1 by 2. This is I2 also same ratio, 2 is to 1 ratio. Here also you get 1 by 2. That's it. So if this is very important, this information. At equilibrium you are calculating dissociation is plays very important role. Based on that only you will get correct answer. This is the best method, students. Practice whatever you are listening the numericals. Comment me if you have any doubts. Now 1, this is 0.5, this is 0.5. Calculate. Kc equal to H2 into, what is this, concentration? Directly I am writing 0.5 into 0.5 by 1. Right? Concentration of products by concentration of reagent. 1 square is nothing but 1 only. Finally, what is the answer? 0.25 is your answer. Clear? That's it. Now, previous video I gave one question. Hope everybody solved this question. So, try to do this one. 2A plus 3B gives rise to 4C plus 5D. Initially 3 moles of A, 2 moles of B taken. 30% of A dissociated till equilibrium. Calculate the total number of moles. They are not asking Kc. They are asking total number of moles. See, students, 2A plus 3B gives rise to 4C plus 5D. Right? 4C plus 5D. Initially how many moles? This is 3 moles. How many moles? This is 2 moles. This is 0. This is 0. Now equilibrium. What is equilibrium information? They are given degree of dissociation. How much? 30%. 30 by 100. How much, students? 0.3. Right or not? 0.3. This is for what? 1 mole. Right or not? This is for only 1 mole. 1 mole 0.3. But 3 moles how much? 3 into 0.3. That's all. We'll substitute here. At equilibrium, how much dissociated? 3 moles means 0.9. Same like 2 moles. Equate. So how to take this one? Stoichiometric coefficients. Don't take directly like this. 2 minus 0.9, 0.9, 0.9. Don't take like that. What is the stoichiometric ratio? 2A reacting means how many moles of B reacting? 2 moles of A, 3 moles of B. 2 is to 3. Now this is 0.9. 2 moles means 0.9. 3 moles how much? 0.9 into 3 by 2. 0.9 into 3 by 2. What is the answer, students? What you will get here? Calculate 2 minus 0.9. 27 by 2. So here nearly you will get 1.35. 1.35 your answer. Check it. 0.9 into 0.9 into 3 by 2. 1.35. Yes, 1.35. 2 minus 1.35. 3 moles means 0.9 disappeared, but 2 moles means how much? 1.35. 1.35. Like that we have to take it. Next step here, what is this? Here what we will take, students? Here 2 is to 4. This is 2. 2A means 4 moles of C appearance. Here you can equate these two also. 3B 4C, 3B 5D also. Anything you can equate. I am taking A and C. See, 2 is to 4. Then 0.9 how much? 4 into 0.9 by 2. 4 into 0.9 by 2 how much, students? Yes, you will get 1.8. 1.8. This is 1.8. Similar way you can take it here also. 5D. So 2A means how many? 5D. 2 is to 5 ratio. 0.9 how much? 0.9 into 5 by 2. What is the answer, students? Here you will get 2.25. 2.25. So now see, first value how much we got it? 0.9. Second value how much we got it? 1.35. Third value 1.8. Fourth value 2.25. So that's all. 2.25. Clear? That's it. Now 3 minus 0.9. How much, students? How much? 2.1. 2.1. 2 minus 1.35. How much? 0.65. 1.8. 2.25. Total number of moles. Add. Total number of moles. Add all. Total number of moles at equilibrium. At equilibrium. Then 2.1 plus 0.65 plus 1.8 plus 2.25. So finally you will get answer 6.8. This is your answer. Clear? Now next one. With this numerical part I have completed. One theory question which is frequently asking in examination. So predicting the direction of the reaction. Predicting 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 the direction of reaction. Direction of reaction. Predicting the direction of reaction. Okay. See here the equilibrium constant. I am writing points. Equilibrium constant helps the predicting the direction in which a given reaction will proceed. In which given reaction proceeds. Proceed at any stage. Okay. For this purpose we are calculating reaction quotient. For this purpose calculate reaction quotient. Reaction quotient. It is represented with the letter Q. Okay. See, students, you know equilibrium constant. What is equilibrium constant? Concentration of products by equilibrium constant Kc equal to, this is equilibrium constant. Okay, Kc equal to concentration of products by concentration of reactants. Concentration is nothing but box. But Q, what about Q? Q also concentration of products by concentration of reactants. This is at any stage. At any stage we are calculating. Initial stage, or else after completing 3/4, after completing 1/4, 50%, anywhere you can calculate. But this is only at equilibrium. This is only at equilibrium. This is the difference. Clear? Now, they are asking Q less than Kc, what happened, forward reaction or backward reaction. To understand this one, I am giving the best trick to you. What is that? Just a simple graph like you can take it. Like this. Okay? This is equilibrium. Exactly Kc is here. Now Qc here, Qc here. Then predict the reaction, students. Predict the reaction. This is Qc, here Qc. Now check it. Here Qc. Okay, now I am writing the points. Now I am writing the points. What is this? First point. What is the first point? QC less than Kc. See, this is K. Here K. Here Kc is there. It is lower part. Lower part is nothing but Qc is less. Qc is less. If Qc is less than Q is less than Kc, then what happened? Reaction will proceed in the direction of the products. Means QC or Q, your wish, anything you can take it. Q or QC, anything you can take it. Q, better. Okay, both are same only. Q less than Kc. Then what happened? Reaction moves forward direction. Reaction moves forward direction. Did you understand point? Forward direction. Simple logic. Reaction moves like this. Okay. Now, next what happened? Second point. Q above this one. That is nothing but Q greater than Kc. Q greater than Kc. That means what happened? Reaction moves backward direction. Backward direction. Right? So this is like this. Next, third point. Q equal to Kc. Reaction at equilibrium. That's it. This is the prediction of the reaction. Okay, students. In the next videos, I am going to do mode of representation of K and Kp-Kc relation numericals also. Hope everybody like this one. Please give likes and subscribe our channel, students. Thank you. Thanks for watching.